Blue team reporting in. This is Champ Unit.
Chandler Cochran, I'm the C.
Jacob Hopkins.
D. Malamudi.
Griffin McMillan.
Carrington Pan.
We were assigned the duty of choosing a design process to bring you a product. With this docu-series, we'll show you the planning, prototyping, casting, and refinement of a genuine sandcasting gear and some friends.
In the beginning, a great meeting of minds was held. We thought about forging, too involved. We thought about extrusion, not fun enough ideas. We wanted it to be metal. Sandcasting, that's it. Many ideas were thrown around. Jewelry, a helmet, balls, but a gear, now that's engineering. A great journey has begun. A preliminary budget made, a basic design document forged, and research had. It was time for development. Sandcasting is an ancient practice involving casting metal with the use of mold packed full of sand with a pattern. The mold comes in two parts, the cope and the drag. Or if you go with open mold sandcasting, like we ultimately did, you'll need just the drag. To get our pattern, we decided to design and manufacture pattern prototypes through additive manufacturing, also known as 3D printing.
So we started with prototype unit 1. With it, we were able to see the future, but in the present. It was too big, not in the budget, changes were needed, so we reduced it down by a quarter scale to be exact. The design document was revised and our budget was finalized. It was time to build the rest.
We started by measuring and marking 6-inch and 6¼ increments on our 2x4x6 for our cope and drag sides. We then used a miter saw to cut the pieces. The volume we wanted for the cope and drag also required us to use a table saw to cut the sides down to 3 inches. After this, we simply used wood screws to join the sides together, forming the boxes. Originally, we had attached a latch in order to secure the cope and drag together during the casting process, but these just proved to get in the way during the sandpacking, so ultimately we removed them.
Before the first attempt at sandcasting our gear, we gathered the necessary materials and tools, which were a furnace with a crucible and tongs to hold the gear, charcoal, which was used as a fuel source for the fire, a hair dryer used as a convection source, and casting sand. We started the process and everything went smoothly until it was time to remove the gear. After several attempts, we failed to remove the gear from the drag cleanly. Because of this, we decided to go with open mold casting to save time. And to save our sanity, we revised and 3D printed Gear Prototype Unit 2.
Okay, so after reprinting a new gear that was shallower and had wider spacing between the teeth, we coated it liberally with baby powder and we packed it with casting sand, and this time we were able to remove it without damaging the mold. So after we did that, we put the aluminum bar into the heated crucible, and since we didn't have anything to cut the aluminum bar, half of it was sticking out into the atmosphere, so it took substantially longer to melt. But upon it becoming molten aluminum, we removed the crucible carefully with tongs, and we removed the slag with a metal spoon, and we slowly poured the molten aluminum into the first drag that we had that had a border around it. And then with the excess aluminum, we were able to fill a second drag of the same mold, and then finally the excess aluminum from that was poured into a muffin tin so that it could be so that it could cool separately. And so in terms of safety measures we did it on an isolated, dry piece of ground, and we had excess sand available in the event of an unexpected fire or other safety hazard, as well as thick leather gloves and thermal sleeves for everyone operating and handling the aluminum. So we waited like an hour for it to cool, and then we carefully removed it from the mold, and you can see past the residual sand and all, there's some excess material on the top due to the open die cast molding. This wasn't die casting, was it?
We asked the machine shop workers to help us decide the best route to finish the gear and how to use the suggested equipment to ensure our safety. We tried using the benchtop sander in the fab lab, but the sandpaper had been used for a different type of metal, making the sanding less effective. We also tried using an angle grinder to cut the burrs off the gear teeth, but it wasn't easy to cut the angles we needed. We ended up moving to the machine shop where we used the aluminum benchtop sander, which allowed us to take layers off the backside of the gear until the burrs were removed. It was hot. Too hot. We would have to quench the gear intermittently to continue the process. We then used a wire brush on a grinder to finish the gear, as well as a metal wire brush to get between the teeth. After we finished polishing, we used the machine shop's laser printer to etch the UGA arch on the gear. How beautiful!
Mission complete. The gear is in the hatch, and some fun mementos with the excess metal to last us a lifetime. What we learned: use a simple design, don't sandcast gears, use other methods. And open mold casting isn't worth the extra time you'll need for machining. But really, at the end of the day, maybe, just maybe, the real treasure was the friends we made along the way. Blue team out!